Okay, I copied the matrix down wrong. Here's the original matrix, okay? So I've just modified throughout because what I got there didn't even have a real solution. And you don't want to deal with complex eigenvalues right now, okay? Probably never in this course. Okay, be fun to do, but you don't want to mess with it yet. Okay, so now if this is corrected, we get this factorization and we get lambda equals 3 or lambda equals -2, right? Okay. So now the process of getting the eigenvalue equation is basically, you can almost skip this stuff. And for right now, I don't care if you do, but it's better if you understand the steps from here to here, okay? But this equation, you just put a minus lambda on this and a minus lambda on this, and then multiply these, subtract what you get here from what you get here, and you get an equation that you can solve for lambda, that you can hopefully solve. As I didn't intend to illustrate, but did, sometimes you get a big positive number here, okay, which tends to give you no solution. Tends to make the discriminant of the quadratic too big, but negative, okay? So it doesn't work. Okay, now that we've got this row and this row become multiples of each other, okay? For either lambda equals 3 or lambda equals -2, these two rows give you the same thing. Now they're multiples, they don't necessarily give you the same equation, okay? So, make sure I get the right numbers. So we have 12, -5 minus lambda. And I'll say for lambda equals 3 or lambda equals -2, the equations in the first and second rows okay. Now the equations are these are your equations. I mean, that's what this matrix equation tells you. First row times the column equals 0. Second row times the column equals 0. And if you don't see that the first row times the column gives you this, and the second row times the column gives you this, okay? Practice more and get used to it. It takes a little while. I mean, if you don't see it now, you really want to see it at the latest by next week, and it needs to be natural and it needs to be something you just see. Okay? If you're still struggling with matrix multiplication, row reduction stuff, get a tutor, see me. Let's figure out what to do. And review, starting with simultaneous equations. Okay, anyhow, so we got these two equations. If lambda is 3, that gives us 6 minus 3x minus 2y equals 0, and 12x minus 8y equals 0, right? Or 3x minus 2y equals 0. 12x minus 8y equals 0. And you can see that this equation is just 4 times this, right? Okay? And why is that? It's because what I said back when we had the matrix of this times this equals this times this, it's got to be. Okay? And you can check 3 times negative 8, negative 2 times 12 are equal. Makes the equations multiples of one another. Whether you totally understand that, believe it. Okay? So, well, if we solve this for y, y equals 3/2 x. And v1 equals x 3/2 x maps, transforms to 3v1. For any x. In particular, I'm going to let x equal 2. Since it works for any x, I can choose any x. And if I choose x equals 2, what in the world is that? Oh, okay. If I choose x equals 2, I get whole numbers here, right? Okay? So now we can come up here and we can see that part of our picture of the transformation is that the vector 2i plus 3j under transformation maps onto the vector 3 times that, 6i plus 9j. Okay? So I better draw bigger y-axis and hope I've got room to draw the other one, but okay? They're in the same direction, but this is 3 times as long. Well, that's just like the picture we had before, except that vector has gone to half, right? Well, it can go to anything. Well, the other equation very quickly, and I'll just write down the result. Lambda equals negative 2 implies, among other things, that 8x minus 2y equals 0, so that y equals 1/4 x, not 4x. Okay?
I'm like, oh God, he's going home. He's going home for all this that.
So x4x would map to negative 2 times x4x.
Should that be negative 4?
No, because when you got opposite signs here, when you
Okay.
put one of these things over on the other side, they're going to be the same sign, right?
Okay.
Now maybe I screwed this one up. Let's see, no, they were opposite signs as well. Okay? Because I can make that mistake, so it's a good question. I'm glad you asked. And in this case, unlikely as it might be, I got it right. Okay? Which means that the vector 1, 4. 1, 4. Whoops. 1, 4. It was like we have V2 equals 1, 4. Okay? And it maps to -2 times that.
See, I have to go.
Yeah, just about done, check the video. So -2 times 1, 4. Be -2i minus 4j. Okay? So things stretch in this way. They stretch by factor 2 along this direction, but in this direction, which is really pretty close to this one, -2, -4, right? So that's kind of messy. It's kind of a weird transformation. It's going to map an ellipse onto something very narrow but long, I think. Okay? Now, if you understand the mechanics of what we did, or at least can imitate it, that's good. If you understand more than that, that's great.